In problem number 5, it says to find the domain and range of the function represented by the graph. So here's the graph. They want you to list the domain and range, and then they want us to determine whether the relation is discrete or continuous. So that's our goal, and that's what we're going to do right now. So here we go. The first thing we need to remember is that domain is just a fancy word for all of the x values, and range is just a fancy word for listing out all of the y values, okay? The way I remember that is that alphabetically, D comes before R in the alphabet, and X comes before Y. Before I realized that, I would always forget which one goes with which, and now it's easy for me to remember. Domain comes before range, X comes before Y, so that's how I remember it. So let's get to work. So domain is where we list all of the X values here, okay? So let's make a list. When I make a list, I like to put it in a bracket like that, and we're gonna list X values. So we like to do it from left to right. So let's start with the smallest X value. So that would be the one most this way. Let's see, this is the dot that's furthest over to the left. So let's see, that X value, that is the point 1, 3. And the X value there is 1. So 1 is part of our domain. Let's do the same thing for all of the others. Okay, so here's our next one. I'm not going to keep writing it out each time. I just did it that first time, but let's see. The X coordinate of this one is 2. All right, the next one would be here. The X coordinate is 3. This one has an X value of 4. This one has an X value of 5. And this one, there's one up there. This one has an X value of 6. So that is our domain for problem number 5. The range is the exact same thing. It's just that you do it with the y values. So here we go. We're going to list them all. And then just like the domain, you see how we went from smallest to biggest? You do the same thing with the range. We're going to go smallest to biggest. So when we're going up and down, can we agree that the smallest y values will be down here? So I'm going to start at the bottom and I'm going to work my way up, okay? And that's how you should do it too. So this is the lowest one. That has a y value of -1. We had to go down 1 to get there. So -1, and let's keep going. This one right here has a y value of 0. Okay, this one here has a y value of 1. All right, there's our next point. That's a y value of 2. This one has a y value of 3. And then what's our last one? This is the highest one, right? This one has a y value of 6. And so now we've just listed the range, and it is that simple, okay? That's what you do. Now, to know whether it's discrete or continuous, the way I remember it is that discrete is just a bunch of dots. They both start with a D. And continuous, the way I remember that is if it's continuous, it keeps going. Continuous keeps, kind of sounds the same, okay? So in this problem, we just see a bunch of dot, 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 dot. Okay, so that one is discrete. Just to give you an example of what it means to keep going, do you see how down here this one it keeps going, keeps going, keeps going, keeps going, keeps going like that? So this would be an example of what it looks like to be continuous, and you'll get there in a little bit as well. But in any case, that's how you do number 5. Domain goes with the x's, range goes with the y's, discrete if it's dots, and if it keeps going, then you would say it's continuous. Thanks for watching.